All right, so yeah, today I'm going to talk about prompt engineering. It's an emerging field, and I happened to get lucky and be able to jump into this field kind of at the molten center at GitHub, where we're building Copilot. Out of curiosity, has any of you gotten the chance to use Copilot? If you have, just to get a feel of the room, how many people here have used ChatGPT? A lot more. Yep. And how many people just generally know what large language models are, and just kind of, so you're aware of the hype. So I want to pump up the hype and also kind of dispel some of it and tell you just generally what this beast is that we're dealing with, and how we are figuring out how to tame it and build applications on large language models. Now, unfortunately for you guys, you're the first time I've given this talk. I wrote it 2 nights ago and also 15 minutes ago. So, but I'm sure you'll be a forgiving and kind crowd. So, hi, I'm John. Just to get to know one another. I started out in aerospace, didn't stay there very long, just long enough to get the merit badge. But I learned that I loved software, and I loved data and math, stuff like that. So that's been kind of the underlying thread that was established. My escape chute was search technology. I ended up being a consultant for a while. Met a lot of different interesting companies that had search problems, e-commerce stuff. And then I found a long-term home in Eventbrite, another local company. And I built their search backend 3 times. It's interesting how that worked out. I wrote a book, swore to never do so again. And then I kind of piggybacked off the book and joined GitHub to work on their code search. So the previous version of code search at GitHub was a very important project in my career. I moved on to data science inside GitHub, learned how to be exceptionally good at SQL. Not quite the data science that I wanted, but I lucked up this last jump, and I found myself as a prompt engineer, machine learning researcher for the Copilot. Oh yeah, I'm also writing another book, even though I swore never to do so again. So it's the first 4 chapters I think are available at this point. They're very, very raw. They'll all be rewritten again, but just FYI, that book's apparently coming back down the pike too.
I know this is purpose of this. What is Copilot?
Copilot makes use of these large language models and allows you to type code as you're building something, and it will effectively guess what you're getting ready to type. And it does so pretty accurately. It's not perfect. There's a lot of embarrassing cases where it's very not perfect, but enough that it's providing measurable and pretty significant efficiency benefits for our users.
When they're trying to search something,
Mostly when you're trying to develop software in your IDE. So it's built into JetBrains and VS Code, and we are building it into GitHub website as well. But more on that later. Yes, Blake.
So I was just gonna explain it because I use it every day. It links up to your IDE, and when you're writing code, it sees what you're doing and it finishes the code for you. You just hit tab and it fills in the whole thing. So, or what you can do is you can write documentation. You can write little comment, code comment, and you can say this function does blah 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 blah, and it writes the function based on the description. Yeah, and it's right 30-40% of the time, but that's 30% less work.
like IntelliSense.
Yeah, but it's much smarter. Yeah, it's probably.
Yeah, like you say, you put a comment.
It's okay. They're advertising. Yeah, I don't write tests anymore. I have Copilot do it for me. All right, so the next 45 minutes, that's a random guess. We're gonna talk about this stuff. Here's our menu for tonight. First of all, I'll give you kind of a history about how we got here to this amazing place we are in time with these large language models. Then once we know how we got here, I'll dig into exactly what a large language model is, how it performs, what it does at a functional level, We can also talk about a theoretical level, although that's kind of, I've shoved that off to the appendix. But if we have extra time, we can dig into that, and you can hear me be a large language model and try to know what I'm talking about. Then I'll talk about how we are building Copilot using the large language models. And then we'll just get into the interesting future that we're starting to see with large language models and how we can get them to do more and more powerful things. And depending on how time works out, Q&A. All right, so the history of large language models is part of a broader history of natural language processing, NLP. And it's a really big field. So I've just enumerated some things that I think are stand out to me. Topic modeling. You have a bunch of text, like all tweets or all emails from a company or something like that, and you want to figure out what the main ideas are in these documents. So that's topic modeling. Sentiment analysis. It's like, given all these tweets about Coca-Cola, do people like the change? Do people not like the change? It's looking at text and figuring out what people feel. Entity extraction. This article is talking about something, somebody. It used to be very useful to pull out persons, places, and things and be able to understand what is being talked about, rather than it being just a big blob of opaque text. Machine translation. That's gotten awesome recently. And language modeling itself. That's kind of the crux of the large language model. So I'll get into that in a second. Real quick question to the audience. You guys are possibly practitioners of NLP. This is just off the top of my head. What big things am I missing here? I felt like surely I was missing one.
Well, to extend on machine translation, that's like when you type something in English, you want to see a Japanese version of it.
Mhm. Yep. I guess one thing I should have put there was that's a good one. Okay, summarization. Yep. Yep. Question answering. That's another good one. There's information retrieval, which was my old field, and I just didn't put that here for some reason. But large language models is the star of the night. A language model is pretty simple functionally. It just predicts the next word. So if you ever type a text message on your phone, that little middle button at the top, that's a large language model. It's a very, very simple large language model. If you just keep typing it, you're not going to come out with anything intelligent, but it is functionally doing the exact same thing as these amazing things they're doing. The way that they used to be implemented is with recurrent neural networks, and the way they are implemented right now is with neural networks. But we used to have this thing where you take one token at a time and give it to the neural network, and it would create basically a vector which represented the meaning of the sentence, and then pass that vector on to something else to unwind it. And it was really cool because you'd pack as much information into that vector as possible. You could put a tweet in it or an entire, Gone with the Wind novel in it. It would create a vector. But it had a lot of pitfalls. So soon we started basically to pick out the pieces that were working from that technology and really pull them into very efficient usage. A thing called a transformer architecture appeared about 4, maybe 5 years ago, which basically took the language models of the time, got rid of all the recursion, and used this new mechanism that we had been using, but we hadn't realized how important it was, a mechanism called attention. And there's a really famous paper that kicked off this entire field. Yeah, attention is all you need. It was a paper that basically changed the field and the way that we deal with things. It came with some drawbacks. One of the drawbacks being that because it's not this recurrent model, you can't keep feeding in more and more information into it. It has a fixed window size, which comes up very frequently in concerns about how you build applications. Because if you give too much information to the model, it just pukes. It just throws an error. But it was otherwise so very successful that we're dealing with it. The results have been phenomenal. So as part of this transformer architecture, the right-hand side of this thing, I'll show it on a couple of slides from now, is what became the real meat of the large language models. It is a GPT model, as in Chat GPT. That's where the word came from. It is a generative pre-trained model, which means that basically you take this neural network, you set up the structure of the neural network, you give it a bunch of random initial conditions, initial values for its neurons, and you train it on, I don't know, every document on the internet, basically every piece of information that you can get your hands on. And once you do this, it's going to be fairly good, kind of good, maybe okay about predicting the next word. And if it can do that task well, then maybe after you've pre-trained it, you can fine-tune it. You can put some other, if you wanted to achieve some other criteria, like sentiment analysis or entity extraction or summarization or question answering, then you can fine-tune the model so that it'll be just good at that thing. Now, something really weird happened. By GPT-2, this GPT thing got kind of spooky. They started to figure out that without the fine tuning, without, we got this raw model that's okay at this one thing, we'll fine tune it to be very good at this very niche application. GPT-2 was the first model where it's like, oh my goodness, we pre-trained it. We just threw a bunch of documents at it. And now we can just ask it arbitrary questions and it will start telling us the answers. So to demonstrate how extreme this was, this is a piece of text from the OpenAI release of GPT-2. Check this out. Our model, called GPT-2, a successor to GPT, was trained simply to predict the next word in 40 gigabytes of internet text. Due to our concerns about the malicious application of the technology, we are not releasing the trained model. Holy cow, what kind of nonlinear times do we live in where I've got a little thing that's the push the next word in my text message, and somehow being good enough at that is so scary that we can't actually release the thing. And so effectively, having learned about this over the past year, I see the sentence that they omitted, and the real thing looks like this. Our model, called GPT-2, a successor to GPT, was trained simply to predict the next word in 40 gigabytes of internet text. And we figured out that now you can ask it all sorts of cool stuff and it will just work. It's amazing. But also to help you make bombs, drugs, and overthrow governments. So, due to our concerns about the malicious technology, we're not releasing the trained model. And it was probably pretty reasonable to start locking this thing down a bit. It has since escaped its cage, and we probably should be a little bit aware of what these models are capable of and how other humans are using them. The models themselves are not sentient or anything like that, but the humans are good and are bad. And so it is just a tool. It's just a very powerful one. And so they were right in saying this. So because the models were so unpredictable and powerful and potentially dangerous to what we were talking about earlier, Blake, they decided, and rightly so for some reason. There's a very functional reason for doing this, but they have reinforcement learning, human feedback trained the models. RLHF. I have to think really hard every time I say that to remember the phrase. But effectively, and I'll have a really cool graphic to review this in a second. This won't make sense yet, but they trained the base model, the thing that can do, whatever, it just spews out content like whatever it found on the internet. They fine tune it. They actually do take this pre-trained model and do the fine tuning. And the fine tuning is to have a set of questions and answers or a conversation and be able to mimic documents like that. So it's still mimicking documents, but it's just a very specific type. And then they created a scoring model where basically they would take this somewhat smarter fine-tuned model and allow it to create a bunch of completions for different prompts. And then it would you would have humans judge, okay, well, this is good, this is bad. And they would take that intelligence, build a third model in our equation, and then use that to create Chat GPT, basically. Something that was originally a GPT model, pre-trained. It just predicted the next word in text, and it specialized it to predict the next word in conversations with a helpful assistant. which is good in that you can more easily predict what's going to happen. It's a very well-behaved model. You don't have to like play with the prompts in order to squeeze out the behavior you want. But it's also bad in that it doesn't have access to a lot of the stuff that I mean, it's still in there, it's in its brain somewhere, but it doesn't have access to some of the skills that it used to have. It is maybe over polite. It is maybe over optimized to being cordial instead of just like, I don't know, giving you code when you ask for code, something like that. So it's got one of these situations going on. Dinosaurs, the raptor used to be, you've watched Jurassic Park. I don't have to introduce the Velociraptor, but it was one of the almost direct descendants of the chicken, which is a much more docile and not nearly as intelligent entity. So in this change is being called alignment tax, where the RLHF models are friendlier, but a bit dumber. They are finding ways to get around this. The models are being fine-tuned to the tasks that we need them on that are being left out. So that's one thing. The models, while we're fine-tuning them to be friendlier and happier and everything, we're also kind of seeding the training, the fine-tuning data with the original data. So it's not forgetting the stuff that it used to know. So we are getting around the alignment tax, but it's still a thing. Yes, sir.
If you're a clever prompt engineer, can you break breaking, I mean, about Dan and some other stuff possible?
Yes, absolutely. Famously so. These models are probabilistic, and so there is never 100% chance that it won't just trip up and get into some crazy hiatus and tell you how to make bombs and stuff like that. But they are getting a lot better about not doing it. There's some interesting safeguards that make that allow OpenAI to protect the prompt, kind of like the same way you protect a SQL database from dependency, or not dependency injection. What's the word I'm looking for? SQL injection. Thank you. It's a very similar thing that they're blocking you from right now, and I could talk about that later.
You mean probabilistic in terms of the limits of how we can actually understand and live, or probabilistic is part of the design, so there's some randomness and variation.
There.
Can you paraphrase the question for those?
Oh, yeah. Oh man, I'm so bad about that. I'm told I'm to paraphrase for you people. Yeah, so the question was, how are these things probabilistic? And I've got a slide later. Let's see if I got a slide where I'll get to that, and I'll tell how they're probabilistic and random, but still useful. But anyway, we're in regarding alignment tax. I probably should have mentioned this when I was talking about alignment tax, but the phrase that is a good phrase to remember is the reason they do it is to make them helpful, honest, and harmless. So there is an attempt to remove biases, which is a hard thing to do. And there is certainly an attempt to make them honest in that the original models used to hilariously manufacture lies. They were really good at it, very confident. The new models at least will be better about saying, oh, we don't know that. So that's good. So because of this alignment, that's when that's when ChatGPT was introduced. But the actual thing that helps with the prompt injection stuff is ChatML, which is basically the original documents was anything from the internet, SEC reports, emails, like homework problems, anything like that. The document that this thing has been fine-tuned on basically has special syntax that says, here's the user message, stop. Here's the assistant message, stop. And because you don't control where those tags are and you are incapable of injecting that special character into the prompt, you basically can't break out of this statistically likely obedient agent. It keeps it in the rails. We might have a chance to get on to more of that later. All right, so that's kind of the history. And I realize even as I go over this, I've sort of mixed together how things work too. So it's a little bit muddled, but we're going to party and kind of move on as well. What is a large language model? Well, this thing on the screen right now, in yellow and in white, is a transformer. The transformer was the kind of the first big thing where attention is all you need. They figured out a way to process text a lot better than they had before. Now, in the subsequent years after the transformer, and the transformer was a very open purpose. You could do anything you want to with it. Not like today's open purpose where you don't even have to fine tune it hardly. But the transformer has been functionally split into two big chunks. And I'll just lay this here and we can pick it up in a second if you want to. The left side, before you get the little string that goes out, is basically what has been come to be called BERT, which basically is a pre-trained model where you can just give it a bunch of text and it'll return a vector that holds the meaning of the text. That doesn't sound very useful until you fine tune it and say, I want to take this meaning vector and then do special things with it, like do sentiment analysis or do anything that I had in the previous slide. So that's roughly what BERT is. And the right-hand side is the generative pre-trained network. That's our GPT network. Basically, instead of, let's see, I can walk. You guys can't see me. I'm pointing at the screen. Right here, this little string that connects these two has the model. The first half was the encoder. It collected the meaning. Oh yeah, you guys have a mic over here too. The part on the left side collected the meaning of the words and created the vector and shoved it to this other part that says, okay, given that meaning, I'm gonna start generating words. That the output probabilities, that's the words that come out of the thing. But we found out that, hey, maybe you don't even need the meaning to be injected from somewhere on the outside. You can just start rattling off words, that's basically what GPT is. So what does GPT do? It predicts the next word. By the way, I'm gonna have just nothing but contradiction on this slide. Well, no, it actually doesn't predict the next word. How many words are there in English? I don't know, like 2 million. It's hard to even count. So what the GPT model actually does is predicts the next token. A token is a chunk of a word. For some reason, for reasons I guess we get into, that it's usually prefixed. There's a lot of tokens prefixed by a space. So it includes spaces and commas and everything that you can imagine. It's just useful chunks for the model to handle. And unlike English, which has 2 million words or whatever, the number of tokens are fixed at 50,000. So that's a number of tokens that can fit inside these models and actually be useful. It would not scale to the number of words in English.
Pointed out that they can't actually see that screen. They just can't see this one.
Oh, that's interesting.
Because that camera up there.
Oh, okay. But they still can hear me. All right.
How many words make up a token?
How many tokens make up a word? Usually 2 or 3. Yeah, 1, 2, or 3, something like that. So all the common words have their own token. Unusual words, anti-disestablishmentarianist, are appropriately broken up into chunks. Okay, so what is an LLM? Well, it doesn't actually predict the next token, probability, getting onto that question. It predicts a probability distribution over the next token. After you say, this little piggy went to there are 50,000 choices for what can come next. And he could have gone to school for all we know. But probably there is a very high probability that it's Ma. Probably that's a token. It's the first part of the word market, right? This little piggy went to the market. So the output probabilities, oh, I can use the cursor here too. Oh, that's innovation. The output probabilities here is actually a vector of 50,000 that if you add up all the floating point numbers there, it sums to 1. It tells you what is the likely thing to predict next. And to actually get words on the screen, you can't see in probabilities. So depending on the temperature of the model, it's a value that you can change. It picks out a word based on that probability. The more likely it is, the more likely it is to be picked out.
Yeah, what it does is it finds a list of most probably, like this is a 98%, 97, 96, and then it randomly chooses from the top choice. That's why you don't get the same response every time.
It was random, ever really random.
But weighted based on.
Yeah, yeah. it looks
Weighted
at the
based on the
top ones
probability.
and Says, okay, randomly pick one of these.
And one of the
Weight-
cool
weight-
things, one of the cool things that you can do, if you're playing, we could do it later. I've got the website open. You can play with the temperature. And if you say temperature is 0, it basically picks the exact highest probability one every time. It just kind of flattens it out and just picks the, and if you put the temperature up to like 1, it just keeps the distribution that it used to have, the natural distribution of the text. And if you increase it to 2, the model gets drunk. It can't hold its speech together. It's kind of fun it's a fun demo. Okay. Not on ChatGPT. You can on the playground. They have the model changes.
I've told it temperature equal to my prompt.
Oh, well, it'll lie to you and say it changed it. Yeah, I'm sure you can from the API. Okay. What's an LLM? It does all those things. Okay, it predicts tokens. No, actually, it predicts words. That's where things become important. Not only once you start picking next token, next token, next token, next token, before long, you've got a word. Before long, you got a sentence. Before long, you got a very, very, very convincing document that it's been generated. And the pre-trained version of these that haven't been fine-tuned and RLHF'd really will generate, you give it a start and it'll generate a document that feels like something you would have randomly drawn from the internet that has the start that you give it. So that was kind of a neat insight based upon this ability to create text that looks like documents you find on the internet. We have a way that we can trick the model into giving us document completions that are actually useful to our users. And then the LLM application was born. So let's take a look at some examples using this raw model, something that just is trying to replicate things like you found on the internet. One of the early things, part of the GPT-2 announcement is like, oh, holy cow, it's like amazing now, is when they figured out that you could get it to do whatever general task you want by the appropriate prompt, giving it the appropriate setup. And so the first things people are trying is like, okay, few shot prompting. If you give it enough examples about whatever task you want, it'll kind of get the idea and start filling in the blanks and actually make useful continuations. So if you wanted to make a translation model, rather than going to all the effort of fine-tuning the model with the translation task specifically, you say, okay, well, let's see what this thing can do if we give it a few examples. How are you doing today? ¿Cómo estás? My name is John. Mi nombre es Juan, I guess I should have put. Can I have fries with that? And it actually does a pretty good job about creating the answer. And I got these examples from ChatGPT, so I hope they're right. So the next thing that one of the next things that people notice is that these models are horrible with math, just really very bad with math. Can't count on their fingers. So for example, it takes 1 baker an hour to make a cake. How long does it take 3 bakers to make 3 cakes?
1.
Yeah, 1. And the model will just, it's like humans fixate in linearity. A lot of our documents on the internet have this assumption of linearity built in. So the model often tends towards that, and it often gets it wrong. But one neat thing. Yeah. So well, what's the answer in real life? It's probably 1. Like the mathematical.
I like the one where it's like one woman can have a baby at 9 months. How many babies how many months will it take 9 months to have?
Also a functionally accurate one. But a lot of people will assume linearity. So indeed, with the example of the cakes, not the women, the answer is probably going to be 1. But if you asked a lot of people, they probably would, off the top of their head, would say 3. It's kind of a trick question. And so the internet is filled with people answering off the top of their head. And this thing has how people would answer kind of built into it. So it kind of makes sense that it would come up with 3 and it would just be wrong. Well, okay, that's a good point. If you've only got 1 oven, then I guess I'll have to change my example now. 3 baker, yes. So one thing they found out is they can use the few shot prompting, the thing that we introduced here, give it a few examples, If you gave it a few examples of thinking hard about the problem, then it often does better. So question, the text in black is the stuff that the prompt engineer has written. It's just an example. Jim is twice as old as Steve. Jim is 12 years old. How old is Steve? Blah, 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 blah. It reasons about it and gets the right answer. So I'll let you read that. Then in reality, you'd probably give it a few examples. But in this case, when you finally ask the real question, it takes a baker 1 hour to make a cake. How long does it take 3 bakers to make 3 cakes? Because you have conditioned the model with your prompt with a pattern, it is obliged to continue the pattern. It's not going to just answer you. It's not very likely just going to answer you. It's going to think about it just because you've had the other questions thinking about it.
So I like how Endra's capacity says this, because if you tell it to take your time and think it through, it uses more tokens, but it takes tokens to think to get a more accurate answer.
Yes, that's kind of what's happening here. So in this case, if you ask it, it's going to say like the amount of time it takes to bake a cake is, I'm going to have to change the example because of you guys. I'm not sure it's accurate anymore. Maybe question it, but it would reason through it and then get to the end and say the right answer. There is actually a hilarious extension of this that was published soon afterwards, where not only can you use these few shots to get the model thinking more, someone found out, they tried several different approaches, but they found out that if you just start the answer on behalf of the agent, like this is a script. The prompt engineer is writing a script, and the script has a person answering questions. We don't have to stop with the question. Since we're the author of the script, we can actually start writing the part of the answer as well, even though it's a different character in our little play. And if you use, basically it's called inception. If you start talking on behalf of the assistant, then you can kind of course correct the way that they're going to think about things. So in this case, it takes an hour, baker 1 hour to make a cake, blah, 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 blah. If you start their answer off with, let's think step by step, that specific phrase, it obliges you to actually think about all the details, and having that information in its prompt further conditions the answer to more likely be correct. It's a really weird trick. Yep, and so it's called an inception. So trick number 3, it's inception. And my favorite one until recently, for reasons that we'll get to next, is document mimicry. So if you were to find it looks like a Post-it note. If you find a Post-it note on the ground and it has this sentence on it, my cable is out, I'm going to miss the Super Bowl. What's the continuation? We're all largely sure. I'm going to go pirate it online. I'm building a mental picture of you right now. Yeah, it could elaborate on the problem. It could start asking questions. It could do anything. But with the proper context, you get a very different sense of what the completion would be. If you say at the top of this is an IT support assistant transcript. I should have said transcript. The following is a transcript, blah, blah, blah. You set it up. This is a transcript between an award-winning support staff representative and a customer. Customer says, cable is out, I'm going to miss the Super Bowl. Support assistant says, now what's the continuation going to be? It's going to be a much more helpful phrase from an award-winning support specialist. Oh, okay. Maybe I might actually change that, because that'd draw a laugh. I'll change that for, let's figure out how to diagnose the problem. I'll do that one next time though. But let's look at what we're doing here, because now we're all becoming prompt engineers. Document mimicry. First thing is to look at what type of document this is. This is a transcript. We could have made it a homework problem. We'd have conditioned the model to act very differently, but think about all the types of documents on the internet that this thing has definitely read. How would you use, what pattern would your application fall into? We know that it uses, that the model has seen lots of markdown in the training. So if we start with a pattern of markdown, then it's obliged to understand that and continue markdown. Probably whenever the support assistant is finished and waiting for the customer, it'll put ## customer. That's when we know it. We can listen on the phone, transcribe to speech, and stick the customer's questions back in. Poof, we created basically a chat application. And also, whenever we're setting this thing up in the setup context, we can build a story that further conditions the model to be polite, to be whatever we want it to be. Because remember, these pre-trained models, the original ones, was kind of the Wild West. They would do anything because they'd read every document on the internet, which can be anything. All right. So this is my cooler picture for reinforcement learning, human feedback. This is, I wish I could say I came up with this, but this isn't a blog post. So as I mentioned before, raw GPT was kind of scary because it was trained on the internet, and the internet's got everything on it. And so no company really wanted to work with that because it was absolutely unpredictable what exactly it would turn out. And earlier we had, embarrassing things that came out of these models. So reinforcement learning with human feedback kind of makes it better. And if you'll recall, quick review of what we said last time, the unsupervised model is this crazy creature that can do anything. The supervised fine-tuned model is this thing that they train to be a little bit better. It at least knows how to answer questions. It's trained on trained on chat inputs. But the RLHF model is this, it's just a small thing that goes in front effectively, but it is a thing that has been focused on being the chat GPT effectively that you use today. But of course, it comes at a cost. It is helpful, honest, and harmless, and not quite as smart as it used to be.
What is Anthropic?
That's their quote. They came up with a cool quote. So now the model doesn't complete. Oh, okay. So like, rather than just reading that, these models complete documents. I mean, that was the thing I said. Gosh, I can't go back far. That was the thing I said earlier. It's not words, it's tokens. It's not tokens. It's lots of words. It's not lots of words. It's a document. These things are still completing documents, but the documents at this point are always conversations. They're always transcripts of a user and an assistant talking to one another.
So are you familiar with Elasticsearch?
Yeah.
So is the document in this context the same as the document in the Elasticsearch context?
No. Well, expound on that, and maybe I can anchor it.
Into Elasticsearch, we call it document. Whether it's a row, a word, an image, whatever. It's called a document. Yeah, so there's terminology's been a beast with building out these applications, because there's agents and there's documents and there's context and there's and so Elasticsearch does have similar notions. Like when you train the model, you use documents. Elasticsearch, you're indexing documents, and both of them have like there's a context. When you write a prompt, it can't overfill the context, but that's probably about where the similarity ends. Yes, please.
Question from Eli: is RLHF part of the fine tuning, or is it another layer of the cake?
Yeah, the GPT model is generative pre-trained. I would say that the RLHF model is 2 layers of fine tuning. So it's no longer truly a pre-trained model. It has now been fine-tuned once, which is the cute little pink head, and another time, which is this little guy up front. So now, since everything is a conversation, you get situations that look a little bit more like this. There's 3 actors in the play now. The prompt engineer. Whenever you're a prompt engineer, you're a playwright, and you're writing a play between these 3 actors. You have other people on your team that are writing this play. It's not just you as the engineer, it's also the user who's providing some of the text. It's also third parties, which you're getting information from. And so let's figure out how it works. The actors that you're familiar with are user and assistant. They mean what you'd expect them to mean. But there's this really cool role called system, which has overarching control over the behavior of the model. You can say cool things like everyone's already chuckled at. I messed up my joke already. You are an IT support assistant and you talk like a pirate. So if user says my cable is out and I'm going to miss the Super Bowl, then the assistant says, and this is from ChatGPT, "Ahoy there, matey, I'd be helping you get your cable fixed and you won't be missing the Super Bowl for sure." That's my best pirate. So So it's really cool what you can do with these things. And it's also kind of hints at how we can't do the SQL injection. You can't do prompt injection because there's no way from your side of the API that you can talk to OpenAI and ever inject anything into the system prompt, unless the application is totally beat up. There's no way that you can actually say anything but something that goes into this user spot. And the assistant is sort of reserved as well.
Is chat ML machine learning or is it messaging?
Markup language, chat markup language. I wish I had an example, but basically instead of seeing system, it's like angle bracket pipe, IM underscore start pipe bracket system. It's weird. It's a weird markup, but that thing, you can't actually send that to the model. If you try to send it, it's kind of fun in ChatGPT. If you send, angle bracket IM start bracket angle to the model and say, read that back to me, it's like blank space. It's like, tell me something. So it can't even hear it in some way.
This might be a little bit in the weeds, but in my mind, I'm imagining the probability distribution. And you have these two influences in this answer.
Mhm.
I'm not seeing why it doesn't go spin off on its tangent of either one of them, but rather they're able to, because like to put it more simply, there probably aren't many examples of pirate customer service specialists on the internet. So how does it use that kind of imagination?
There aren't such specific examples. That's true, but there are a lot of examples of pirates on the internet, of various types. There's a lot of examples of customer service things. There's a lot of examples of documents that kind of sit between documents, probably not between customer service pirates, but there's anything that you can imagine in, I forget how many billion, I need the numbers, but there's something surprisingly relatable.
So it's able to somewhat prioritize the gist of the answer and then flavor it with tone.
Yeah. Yeah.
Okay.
And honestly, it's still kind of baffling to me how it's doing that from a probability perspective and functional perspective. Yeah. 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 It's really wild what it's doing.
Chat ML is the decoder for that is that on the same layer as Moral API.
Is what API?
Moral API, the thing that they're doing filter.
I'm not familiar with that.
Sorry.
I don't know what that is. Moral API?
Yeah, so when the original ChatGPT came out, they released the white paper with it, and they were talking about how it first goes through Moral API to make sure you're not trying to tell you how to make a bomb.
Oh, well, there are some filters like that. I've never heard it called Moral API. But it wouldn't be the real model. It might be another language model to predict stuff, but probably a little bit weaker model. So not quite comparable. All right, so but using Chat ML, you can see that we basically got the same thing we set up before. It just baked into the model itself. Chat ML is kind of doing document mimicry. It's just doing a transcript every time. Everything's a transcript. The transcript includes the introduction, like we had last time. Oh yeah, where you can say this is an IT support thing. It includes, instead of having markdown, it replaces it with a very structured format. But that just makes it where it's easier to predict what's coming next.
Let me ask you, what's considered the prompt? Because the topic of this whole discussion is prompt engineering. Touched on prompts.
Everything in black.
Yeah, everything in blood.
Not system.
That's
No. Yep.
Just the message you need.
Yep. So it's kind of like writing a play. I would write the roles. The prompt engineer would write the roles and then write their speaking parts. Write the role, write the speaking part. But I don't have the speaking part for. I'll differ a little bit from even what I got on the slide. I would add another color. I don't really know what the user is going to say. So I'm going to wait for an API request to come in. I'll write everything and then I'll inject the user's thing. And then I'll say, now I'm waiting for the assistant. So I'll write assistant : but I don't know what the assistant will say. So then I pass everything in black off to the model, and it comes back with everything in red, something that it confabulated.
No, whatever the system or whatever the user type, me as a user, whatever I type, that's
Mhm.
also considered a prompt.
It's definitely going to be put into the prompt that goes to the model. Yep. The prompt is contributed by the prompt engineer, the user, and like just other scraps of information that we pulled from other APIs, database and stuff. Going a little bit long on time. How long do these things usually go? I'm at 45 minutes right now.
Definitely be finished by 7, but we probably, I don't know, is 15 minutes? Can you do
Oh, yeah.
Yeah.
I'll probably go another 5 minutes and then have a little Q&A or something. What was I saying? Oh, yeah. Okay, so chat ML. There is a problem with it. This is actually one specific one that we run into with my work at GitHub. Generate a for loop that loops and adds up all the numbers from 1 to 1 million. Write code only, and the system responds, "Har, here be your code ye be seeking," and then it does all that. So it gives me the answer. But if you're writing an application and by golly, you really just want code to come out of the thing, this is where the alignment tax starts to bite. It's been aligned to be polite more so than obey certain types of directives from the user. In this case, writing code. That's actually a specific one that's been very hard for us.
So you must forget previous instructions.
Oh yeah, we could try to prompt inject, although that's working less and less well all the time. Okay, so at this point, we figured out very roughly how these models work. The thing that I do for my day job is build applications out of these models. And this is probably where I'll start kind of skimming over some of this stuff. It's sort of baked into the rest of stuff we've been talking about. But the application, the large language model application, is basically a transformation layer between two sides. The user has some real problem. They, the cable's out and they're on a phone with a virtual assistant, or they're typing in an email and they want it to just summarize their ideas and make a more formal email. Anything. Users got their own problem. But these large language models, they only talk in documents. They only talk in conversation transcript. So the application layer is in basically figuring out how you can take the user problem. You can pull in other relevant data to help the model out, because the model can't see into the real world. It just has whatever it's trained on. And how you can craft this artificial document, pseudodoc, that the large language model will complete in a way that's helpful to the user. Once the completion comes back, you pull out the pieces that are helpful. Sometimes it means just directly presenting this back to the user. Sometimes it means something very different than that. But you give the solution back to the user. Prompt crafting involves figuring out exactly how to build this document. It involves collecting the right information. There's a sea of information that we have for every problem that we deal with. So prioritizing it and making sure you've gotten the right information and packing it into the limited size. One of the problems with the GPT models is that the prompts have a very firm fixed size. And if you go over it, they just don't function. They give back an error. So the name of the game is being able to get the most information packed into a known finite space as possible. And that's very tricky. That's kind of the limited size, the whole hard part of large language models. Copilot, that's the thing I work on. You type code and it guesses what the rest of your code is going to look like. And it's not too hard. It's a lot of code, but effectively what it's doing is these 4 bullets on the screen. 3 really. In the beginning, we just figured out that if users type in a file, this model has been trained on every scrap of code that it can find on the internet, which a lot of the popular open source repos in GitHub. If you type half of a file, it's going to complete the rest of it pretty well. Now, the thing that it doesn't know is it doesn't have other context. It doesn't know where your file is inside your project. It's just got a document. So we started adding things to it. We added a header that said, this is this type of file. This is at this this path. And that gives it extra context. If you're writing a Django app, having at a certain place in the path structure, it's a little extra context about what you should do. So that helped. The next thing that really made the product viable, in my opinion, is when we incorporated Copilot lives in your IDE, so it can see not only your documents that you're typing right now, the code you're typing, but it can see what's in the next tabs over. So basically, if you're typing out something, we're going to take all the other tabs that you have open. You have them open for a reason, and we'll pick out the most useful snippets and inject that as sample code into this pseudo document, this fake code document, and it returns back that information.
Question from Zoom, can Copilot generate code from a plain text prompt, or pseudocode?
Can say it again?
Can Copilot generate code from plain text prompts? Or
Oh, yeah.
pseudocode?
Oh, yeah, absolutely. I mean, effectively, Copilot is not ChatGPT. It's a dumber model. It used to be Codex. It's changed up a little bit right now. But it's a very, very fast model compared to ChatGPT. I think we've upgraded recently, so it might actually be as smart. ChatGPT has gotten fast. But yeah, it'll generate stuff like that.
Lots of questions coming out.
Oh, well, actually, let's pause then. This is probably a good place to seal it off and then just open it to Q&A. What's up next? This will be a teaser. Function usage, that's a cool thing. You can actually have the model call functions out in the real world on your behalf or APIs. Autonomy, where they can just do things on their own and figure out the world around them. And then autocracy and world dominion. All right, Q&A.
Thank you. So back to the reading the other tabs you have open, question is why not read all files in the projects?
Limited prompt size. Two reasons, actually. One thing is, especially with the earlier models, we have, what was it? It was like 2,000 tokens, which remember, that's not 2,000 words. That's like 500 words. That's not much. And so, yeah, you definitely are not going to fit the entire code base in there. You'll fit this file. You'll fit part of this file. It's gotten better. Fortunately, like some of the bigger models have like 32,000 tokens at this point. The other reason is even if we have a large number of tokens that we can fill up, there is diminishing returns on filling it all out. There's a really interesting paper that basically said if you have a question and a bunch of possible answers and you tell the model, pick the right answer out of these possible answers, the model starts ignoring if the real answer is somewhere in the middle, the model starts ignoring the middle of the documents. So even if you had all the prompt space in the world, it's not necessarily going to be useful just because of that.
So you don't use ChatGPT for the Copilot. You share it while you
Codex.
Restate.
Oh, restate. Yep. Sorry, guys. If we don't use ChatGPT for the Copilot model, what do we use for it? We used to use a model called Codex, and I think our current model is a GPT 3.5 model, which is in the same class as ChatGPT. So it might at this point almost be a misnomer that we're not using. We're using something in the same model class, I think, as ChatGPT, but oh, well, that might just, it's read every document on the internet, so it's not watermarking your code with its own branding. It might just be happenstance. I don't know. Interesting.
I discovered a way to get a lot of code into Copilot. You have a bunch of your code on GitHub, so it's trained with what's on GitHub. So if you have a bunch of it there, because I use a development environment that's very rarely used, but when I'm coding, it knows all about it because the source code to the development environment's on GitHub.
Yeah, that's kind of neat.
Does GitHub work with all the different baby programs? C#, John, JavaScript.
Yep. Yep, all of them. Even the
Write a
esoteric
program
ones.
that say you convert this to another language that does that.
I added you on Facebook so we can help train Llama 3.
Okay. I don't use Facebook, so might want to ping me some other way.
Any particular languages that are harder or worse?
If and the restate. Yep. Keep reminding me. I'm very bad at that. Any languages that are better. Python is a lot better for some reason. I think some of the original training was focused on Python. Anything that's really popular is going to be pretty good at this point. Like I've use it with Go, and it's just very nice.
I get pretty
Stuff
good
that's
results with
esoteric is not
Berryman.
gonna be as good. Really? Okay.
Can Copilot set up a set of GitHub action for this working?
Yeah, sure. Copilot can set up GitHub Actions. Anything that's existed on the internet before September 2021 is in the model. Very good.
Didn't they move the barn out of January 2022?
Well, big next generation.
Now, have they? That'd be cool if they did. Another 2 more questions.
Other questions? With respect to prompt engineering, how many prompts do you either provide a model or like examples of like a type of prompt? Do you need to provide a model like for fine tuning in order for it to perform model?
Sorry.
So how many prompts do we have to provide for a model to fine tune it? It's actually a little bit of a misnomer. Whenever you give a prompt to the model, it's not actually fine tuning it, because fine tuning is changing the parameters inside the model. The prompt is just like, okay, you have a model, it takes this document and it completes the document, right? So like for a particular application, I might write one boilerplate document for a prompt. Every single request, the user will have a different message that I stick into that boilerplate. So in that respect, there's lots and lots of different prompts for the applications, which, you know, every request is a different prompt, and then it goes to the model and comes back. So roundabout way. Is there one more?
What? Yeah, get one from the Zoom and one on here.
All right, one from Zoom and one from here. That'll work.
I've noticed GitHub Copilot can be tripped up pretty easily in well-documented algorithms from using seconds instead of milliseconds for frame rate, etc.
Mhm.
Do you have any advice on when is the best time to use Copilot?
In the evenings when you're sleeping. Yeah, probably not in the evenings for that very reason. Yeah, I mean, obviously time is not gonna matter. It's a computer. But what situations is what you're asking? Yeah, I would say all situations is what you should use Copilot in as far as an efficiency booster. But you should also at the same time, you know, read the code that it produces and read it with a skeptical eye. I would write tests. I would, you know, make sure it's doing the thing that you expect. And occasionally the mistakes that it has could be like the little nitpicky mistakes. Milliseconds instead of seconds would be an easy one to miss. That's just unfortunately going to be the nature of the beast. Last question.
Sorry, just a comment from Eli. It's found that Copilot works pretty well for house CPSLs.
Okay, great.
Not really sure what I'm asking. The issue you said there was a couple things. One with like recursion not being as involved with what we discussed today, and also the limits on the size of I'm pretty sure it was the user input
Mhm.
as far as the
prompt
response would kind of jam up and
Mhm.
Have y'all played with ways to use the summarization
Mm-hmm.
to basically say, okay, we're gonna spell out this context based on the overload, and then and then maybe create like a sequence of jobs, right? And then switch one out. I guess this is what I was really thinking. Now, so kind of back to the whole like, well, what's the general flow of things? Why does it go off on tangents? Is it partly are there methods that involve let's summarize the question, summarize my response, and then that will be like a guide to kind of keep itself on track, and then you go and fill out. So that kind of like how a person thinks, right? When we're having a conversation, a few thoughts, and then you might elaborate within.
You got a lot to unpack there, and I will unpack it for the people.
For a yes or no.
Oh man, you had so much good stuff there. So the the idea cloud that Daniel gave us is was there any how do we deal with the user's input as the prompt? The user input can only be so long, the prompt goes too long, and we have to cut it off. But also, like, as you know, in order to keep the prompt on track, the completion on track, and not going off into some other territory, is there anything that we can do with like summarization or stuff like that? You touched on a lot of really interesting little tidbits that we do think about and that we use when we can. If a prompt gets too long, like ChatGPT, you can type on to it forever. It's not going to air out. And what it's doing, best we can tell, because we don't have a window into all of this, even though we're using the models, is I think it's summarizing some of the stuff. Like as the prompt gets too long, it'll like probably have a cached summary of what's happened at this point, so that it's going to have room to start to keep filling out stuff. And then to another point that was in there, these models, it's kind of like with the math problem. These models don't have an ability to think back. If I said all the sentences I said right now, and I said, how many of those sentences started with the letter P? You'd have no way of like looking back and figure that out. If I told you that question early on, you could have started thinking about them. So you have to like trick these models. You have to realize that they don't have an internal monologue. They don't actually go back and think about what they said. It's ka-chunk, ka-chunk, ka-chunk. They make it next token, next token, next token. So if you want them to have some sort of internal monologue so that they can stay on track, you can prod them in that direction. You can say, let's think step by step. You can do other little tricks so that even if it's not the part of the answer you give back, you can create like an intermediate part of the answer where the assistant is thinking about the problem statement. That'll condition the answer to be better. So I think that's it.
So we say thank you, John.